Welcome back to my channel. So this video I will be discussing about diffusion pressure deficit, DPD, and or diffusion pressure deficit, or this is also called as suction pressure. This is also called as suction pressure. This is very important topic for the NEET. About 4 to 5 years back, question on DPD was given. So let us briefly discuss what is DPD and what is the meaning of DPD. So before actually start with DPD, I would like to tell you the what is osmotic pressure and what is osmotic potential. So these two terms are very important to understand DPD and even water potential also. DPD in fact is an older term for water potential. Water potential is the more recent term. DPD is the older term. So DPD also explains the movement of water. It is a concept which explains water movement. So both water potential and DPD, they explain the concept of water movement, how water movement takes place. That is explained by these two concepts. So before actually we start with it, let us understand what is osmotic pressure and osmotic potential. So in a solution when we observe, how do you differentiate these two? What is osmotic pressure and potential? So if we take osmotic pressure, it is due to entry of water. When water enters into any system, then the pressure which is developed with water, we call it as osmotic pressure. Osmotic potential is due to presence of solute. When solute particles are present, that changes the concentration of the solution, then we call it as an osmotic potential. And second point, it increases with increase in concentration of solute. So as we increase the concentration, osmotic potential also will increase. That means osmotic potential is directly proportional to concentration. Whereas osmotic potential, it decreases with decrease or increase in concentration, not decrease, sorry. You should take it as increase. So when you increase the concentration, increase. It decreases with increase in concentration of the solute. So both are opposite. With respect to concentration, both are opposite. It is a positive value. Next feature, next point is it is a positive value, whereas osmotic potential is a negative value. And both are equal in magnitude. That means both are equal. But they are opposite in sign. So suppose this we take it as +5, this we should take it as -5. The unit I told you -5 bars, or here if you take it will be +5 bars. So both are equal in magnitude, in quantity, but they are opposite in their sign. And with regard to water movement, water always moves from a region of lower osmotic pressure to a region of higher osmotic pressure. Lower osmotic pressure, it means it is lower concentration to higher concentration. In terms of concentration, it is from lower to higher concentration. And in terms of osmotic potential, it moves from higher osmotic potential to lower osmotic potential. Lower osmotic potential. Higher osmotic potential with increase in osmotic potential. So when will osmotic potential will be higher? When its concentration is low. And what is the meaning of higher osmotic potential? We should call it as less negative. In terms of value, less negative osmotic potential. What is in less negative? Suppose if we take this as, say, this side -2, this side we should take it as any higher number, say -4. So -2 will be higher osmotic potential. It will move towards -4, which is a lower osmotic potential. These are the differences between osmotic pressure and osmotic potential. Now let us go through, start with what is a DPD. We will start with what is a DPD, or diffusion pressure deficit. So first we will see what exactly is the meaning of, or what is the meaning of a diffusion pressure. What do you mean by diffusion pressure. Then we will see what is its deficit. Diffusion pressure means the total amount of water present in any system. Total amount of water. That means free water. So total amount of free water present in any system. Free water present. Then we call it as diffusion. Diffusion pressure. So for a free water, that means it is not bound to any solute particles. In a free water, we find there is a high free energy also, or kinetic energy. There is a high free energy or high kinetic energy. So high kinetic energy or free energy, it means there is a high diffusion pressure also. There is a high diffusion pressure. So in a pure water, we find there is a high diffusion pressure. So where do we find high diffusion pressure? In pure water. In pure water, we find high diffusion pressure. But when we add solute to the pure water, we are increasing the concentration. So when we add solute to pure water, what happens? When solute is added, its diffusion pressure will decrease. When solute is added, diffusion pressure will decrease. That decrease in diffusion pressure due to addition of solute, that we call it as DPD. So DPD is the decrease in diffusion pressure due to addition of solute. Comparing to solvent in a system, and when we add a solute, when we compare these two. So diffusion pressure, when it decreases due to addition of solute in a system or to a solution, that decrease of diffusion pressure is called as a DPD. So when we add more and more solute, when we add more and more solute, there will be more and more decrease in the diffusion pressure. That means this DPD is directly proportional to concentration of solute. DPD is directly proportional to concentration of solute. So when we add more and more solute, there will be more and more decrease in diffusion pressure. The decrease in diffusion pressure, we are describing it as a DPD. So DPD will be directly proportional to concentration of solute. So when we take the movement of water in terms of DPD, water always will move from water movement always will be from lower DPD to higher DPD. Water always will move from lower DPD to higher DPD. Lower DPD means lower concentration. Lower DPD is lower concentration to higher concentration. Water will move from lower to higher concentration. So in terms of water potential, how do we equate this? So lower concentration means higher water potential. Higher water potential to lower water potential. So this is how we can relate DPD and water potential. Both are opposite in sign. DPD is always, it is positive. DPD is a positive value, whereas water potential is a negative value. So this is how we can differentiate between DPD and water potential. Now we will consider DPD under two conditions, that is in a turgid cell and in a flaccid cell. So when we consider first in a turgid cell, so DPD, before that we can, there is an expression to calculate DPD, to estimate DPD. DPD is equal to OP minus TP. DPD is equal to OP minus TP. OP minus TP. OP here is osmotic pressure. OP means it is an osmotic pressure, and TP is turgor pressure. OP is osmotic pressure and TP is turgor pressure. So DPD is the difference of osmotic pressure and turgor pressure. So osmotic pressure normally is more than turgor pressure. So difference between these two will be DPD. DPD is always a positive value. Osmotic pressure also is a positive value and turgor pressure also is a positive value. So since DPD is positive, we find always osmotic pressure in a cell is more than turgor pressure. Now we will see this expression in two conditions, two stages. First one, in case of a turgid cell. If we take in case of a turgid cell, a turgidity is developed in a cell due to entry of water. So when turgidity is developed, what we find is turgor pressure will increase. So turgid cell is due to entry of water. Turgid cell is due to entry of water. So when water enters into the cell, we find turgor pressure increases and its osmotic pressure will decrease. Osmotic pressure will decrease here because concentration decrease. Because due to entry of water, the solution will become more dilute. So concentration will decrease. So when concentration decreases, osmotic pressure decreases. Turgor pressure will increase. So at one point, both will become equal. Both will become equal at one point. So when both will become equal, then what happens? When OP is equal to TP. Suppose we take OP as 10. TP also will become 10. So what will be DPD here? DPD will be 10 minus 10. That will be 0. So in a turgid cell, we find DPD will become 0. Turgid cell. The same thing we find with water potential also. Water potential is maximum in a turgid cell. That means it becomes 0 in a turgid cell. This is in case of turgid. Now let us see in case of a flaccid cell. In case of a flaccid cell. So in flaccid cell. Flaccid cell will start losing water. So in flaccid cell what happens? It loses water. So when it loses water, the turgor pressure will decrease. So at one stage the turgor pressure will become 0. Turgor pressure will decrease and it becomes 0 in a flaccid cell. So in this expression, when turgor pressure becomes 0, we can give it as DPD is equal to OP. So if it is a flaccid cell, DPD will be equal to its osmotic pressure. So this is how you have to know this much about DPD. In my next video, I will be discussing about some of the numericals which are involved here, both in water potential as well as in DPD. Now, lastly, what I want to do is, I will just summarize the water movement with respect to all these which we discussed, all these aspects. How does the water movement can take place? So, water movement. So, how can we say? First, we will say water movement in terms of water potential. Suppose we give in terms of water potential. How do we give? Water moves from higher water potential to lower water potential. Water moves from higher to lower. Suppose we take in terms of osmotic potential. Suppose we explain in terms of osmotic potential, also will be the same. Higher osmotic potential to lower osmotic potential. Next we will give in terms of osmotic pressure. Osmotic pressure, it is from lower osmotic pressure to higher osmotic pressure. Then if we give in terms of DP, DP means diffusion pressure. Diffusion pressure, it will be higher diffusion pressure to that of the lower diffusion pressure. If we take DPD, it is opposite. lower DPD to higher DPD. Lower DPD to higher DPD. Lastly, if we take in terms of concentration, it will be from lower concentration to higher concentration. So this is how these different aspects we can explain the what is the direction of water movement. So here I conclude this, children. In my next video, based on the same topics, I am going to discuss some numericals. So follow this, write it down, and once again these are very important topics for NEET point of view and difficult to understand also. So once again, once or twice you have to watch it and then practice it. So any other doubts or any clarifications, you can definitely keep it in my description comment box, so that I will be observing that and try to clarify. So thank you very much, children. Have a good day.